Welcome everyone to this week's latest in Bitcoin Tech session. This week we'll try to understand what BIP-10, BIP-110 is about. Go a little into the technical aspects of the changes that the BIP proposes, and also examine the activation mechanism that the BIP proposes, and also look at some of the criticisms or challenges associated with the BIP. So the BIP itself is a temporary soft fork proposed to be like the proposed changes itself will auto expire in 1 year time. It is more of a temporary pause that that uh, that is to be imposed on the network, so as people can like take a moment and gather their thoughts about the current debate around data storage in the network. It is by no means permanent proposed to be a permanent change. It is proposed as a temporary change. It has been put forth by a dev called Om in October 2025. So basically, it is the changes are all directed towards uh, restricting data storage inside the chain. So we'll briefly go over the technical changes that this BIP brings in. We'll have a look at each of these technical changes in a little bit of detail. We'll see what is the rationale behind all these changes, and we'll also look at the activation framework that this BIP proposes, and what how can a chain split occur in this BIP, and the criticisms. And also put to clarify, this BIP has nothing to do with the course BIP BIP structure or BIP procedures. This BIP-110 number has not been granted to this soft fork proposal by core. It is completely devoid of any involvement by the course team. It is more from the knots team. So don't get confused. This is completely arbitrary. BIP-110 introduced by the put forth by the author itself. Okay. So the first change is that the BIP will restrict the amount of data that can go into script pub key to 34 bytes. So as we all know, there are different types of script pub keys. Here you can see a list of different types of script pub keys, standard script pub keys. One is pay to public key hash, pay to witness public key hash, pay to witness script hash, and pay to taproot. So each has its own structure. The script pub key will have its own structure. Typically, a pay to public key hash will consume only 25 bytes. Way to P2WP KH will consume only 22 bytes, and so on.
Talk a bit more about LNHance,
Considering
right?
these
This specific core.
standard script type, considering these standard script pub key types, we can see that the taproot script pub key is the largest with 34 bytes. Considering that, the soft fork proposes a 34 byte limit on the script pub key size. So that means the whole rationale is behind this is that people, in order to deter people from using script pub key to store arbitrary data, people have been storing arbitrary data in script pub keys also. For example, you could not use any of these script pub keys and put arbitrary data. Of course, the fund that you send into an arbitrary script pub key will become unspendable. But the whole point of data storage is to spend some coins and or burn some coins and make the information associated with the transaction permanently etched in the blockchain. So people have been doing that. So this first restriction is to stop people from using script pub keys as a means of storing data. So this is the first restriction that is proposed in the BIP-110. The second one is that it brings back or restores the original rule of using only one op return per transaction, and each op return will be limited by 83 bytes. So nothing has changed here except that it brings back it reverses the condition to pre Bitcoin Core V30 state. So that is about this restriction. Then the third one is that um, op push data payloads will be capped by 256 bytes. So there are three types of opcodes that push that allow your script to push data into the stack. That it is op push data 1, 2, and 4. Each have different sizes of data that can be pushed onto the stack. So push data 1 is the lowest, which will allow you to push somewhere between 76 to 255 bytes. Similarly, push data 2, it will allow you to push up to 65,000 bytes. And push data 4 allows you to push up to it's a huge number of bytes. So we might not have come across any script using these things because none of the standard scripts that we use every day has any need for these push data opcodes. So these are like very niche opcodes that are required for some complex operations. So but as you can see, this push data 1 and 2 have like significantly large byte pushing capabilities, and this could potentially be used to store data. For example, in combination with the false op if condition, this these opcodes can be used to store arbitrary data in the script. So that is one potential, and in order to prevent abuse of this, um, the new BIP sort of restricts the use of op push data, and they are all capped at 256 bytes. It doesn't matter whether you use or push data 1 or 2 or 4, you can push at the maximum of 256 bytes. So that is another restriction that this pip proposes. um, so the next change or restriction that BIP-110 wants to bring in um, is to restrict you from spending or from using any other witness data structures apart from witness V0 and V1, which is taproot. So after SegWit, a new data structure was introduced in the transactions structure. So the witness version that SegWit introduced is V0, witness V0. It has like two types of witness in the V0 version. So it can be either signature followed by public key or something of this structure. So this corresponds to a witness that you put in to satisfy your pay to public witness public key hash type of script pub key, that is this. And this is the type of witness structure that you will be putting in to satisfy a script pub key of this type, pay to witness script hash type. So these are the only two types of witnesses that are associated with V0. So this will be allowed. You can put in witness of any of these two type. Then there is witness type version 1. It was introduced in the BIP in the taproot change BIP via BIP 341. So it has this witness V1 has two types. It can be either just a 64 or 65 byte SNOR signature, which is nothing but a key path spending witness. And there is another three block witness type, which includes a script input, script and control block. So this corresponds to the script path spending. So this is allowed. So all other types, like you can't put in any other type of data into this witness field. So it has to be either uh, witness V0 type or V1 type. It cannot be an undefined type. So that is another restriction that is brought in BIP-110. Following that, there is something called as annex in your taproot's witness structure. So what annex does is that let's say you have you want to use a key path spending witness. You put in your SNOR signature and you follow it with 050. So if you follow this 65 byte with 050, then what this signals to the taproot system is that you are like looking to use this annexure to bring in some soft fork or add some extensions. So using this hex code of 50 after any of your V1 witnesses will signal the use of annex, and this annex is sort of undefined, and it is like envisioned to be used for future soft fork or feature extensions to any of these taproot any of within the taproot architecture. So people have been using this annex also to store some data. So that's why this proposal wants to ban the use of taproot annex. So this is another change. And then comes the control block. So if you look at this script path witness spending, you can see one data structure called as control block. This control block can be expanded like this. So basically, a control block is typically where most of the information about your tap script, tap leaves, and the path which is used to reach your particular leaf in the tap tree are all specified. So this control block basically defines how to find the leaf in your tap tree. So, but people have been abusing this control block to store data. So this is the basic formula for calculating the control block number of control block bytes. So it's 1 byte plus 32 byte plus 32 byte times the depth. That is, if you can imagine a tree with different levels of branches, the control block size is defined by the total depth of your trees branches. So if you have like only two branch, one in the left and one in the right, then the depth of the tree is just one, and you will have a control block of size 1 plus 32 plus 32. You can like imagine what I'm trying to convey. So now what BIP 110 proposes is that we should limit this depth to 7. uh, but it doesn't specify the depth to be of 7, but it specifies that the control block itself should be limited to 257 bytes. So if the control block has to be 257 bytes, and if you plug this 257 into the equation and solve for m, you'll get a maximum depth of 7. So essentially what this restriction is saying is that um, is that you have it is but is that you have to limit your taproot script path spending to maximum of 7 depths, or 128 leaves per tree. So so this is so you have to have a script path spending with maximum of, you can have script paths with maximum of 128 leaves. That's what this limits to. But theoretically, Taproot supports up to 2 per 128. So that is like 3.14 into 10 power 38 script leaves. So it's a huge number. um, that's why Taproot is like a big um, a version of possibilities which you can tinker a lot with. So so once the rationale is that once you limit the depth to maximum of 128 leaves, it gives you reasonable depth to realize complex spending conditions that you want to do, or want to realize with the tap root structure, while also restricting you from doing crazy stuffs. So that's the whole idea behind restricting the control block depth byte size. So yeah, that is one, and the next limitation is preventing use of op success. Um, so in Taproot, there is a opcode called as op success. It is nothing but when the script execution engine comes across this opcode, irrespective of what is there in the stack or what is next in the script execution pathway, it just the script whole script execution exits with a true flag. So that means the transaction, let's say the script execution becomes valid. So this it causes immediate unconditional script validation success. So this has the reason for using this is that it has been put forth as a placeholder, so that you can introduce futures of folks where you want to introduce specific opcodes, let's say like opcat or opctv, things like that. If you want to introduce those kinds of things, you can like just write a code for the opcode that you want to realize, and replace this op success opcodes in the whole in the code with that particular module. So that will be enough, and you don't have to do any further changes to the script engine, or the script engine will automatically recognize the new opcode that has been plugged in. So that's why these op success opcodes exist in Taproot. So the problem is that people can or I think they have also been exploiting this hole in order to store data here and there within the taproot structure. And BIP-110 wants to completely stop the usage of these opcodes in order to prevent arbitrary data storage. And the next one is op-if and op-not-if instructions. So this is a very famous or frequently used attack pattern. This is used by inscriptions. How inscriptions inscribe data is that if you go into the tap tree structure of an inscription, you'll find this pattern of opcodes. So whatever data you want to store, you split it into chunks. So the first chunk goes on the top. Then you have an op-if, and then you have some legitimate spending script which will execute to be true. And in the else condition, you stuff all other arbitrary data that you want to stuff. The whole idea is that op-if will always be true. There will be no condition in which this op-if will turn out to be false, and the op-else will never be accessed by the script engine. So if that is the case, because this script is a whole package, and the else condition should also be carried along with the if condition, the data that has been stuffed into the else condition will always be there. And because this else condition is never touched upon, this will not cause any failure of the script. So it just remains inside, and and it has found a new place to stay within the script and within the taproot structure. So this is how inscriptions are stuffed. So what BIP-10 proposes is that we completely stop using scripts that execute op-if or op-not-if instructions. So if the if the script execution engine comes across an op-if op-if script within the taproot structure, it will immediately reject it as an invalid transaction. So that's the proposed mechanism for these things. So we have looked at the different technical restrictions that BIP-110 wants to impose in order to control data. I'll pause for a few more seconds. If you have any questions on this, we'll discuss. The next one is activation framework and other stuffs. The activation framework. So this is where BIP-110 is taking a different approach. So it is there is one BIP related to activation for frameworks to be used for soft forks. That is BIP-9. The traditional approach is that you will put forth a new soft fork and also a client for that implements that particular soft fork. What miners will do is that the miners will start signaling support for that particular soft fork using one of the version bits in the in the block. And it also has a threshold associated with it. So you will have a time period and a percentage threshold. If there is overwhelming hash rate that signals for this soft fork, and within the required time period, the soft fork is considered to be as active. Otherwise, it is considered to be as fail. So that is a traditional BIP-9 approach. Within this, there are two different two different mechanisms. One is MASP, that is minor activated soft fork, and the other is UASF, user activated soft fork. The difference is that minor activated soft fork relies largely on signaling by minor. User activated soft fork relies largely on signaling by nodes. So these are the general outlay of soft fork activation frameworks that exist within Bitcoin. What BIP-110 wants to do is that it is slightly different. The whole idea is that there is a 55% hash rate threshold that is been put forth, and a time limit till September 2026 has been put forth. So the whole idea is that by September 2026, if 55% of the hash rate start signaling for this new BIP version, then the soft fork is will kick in. So the basic difference is that it will start as a it will start as a minor activated soft fork. That is, initially there is this requirement of 55% of the hash rate or minus should be signaling for this soft fork. And post this 55% signaling, even if there is no improvement in minus signaling for it, the soft fork will become active. So at that point, it becomes like the minor activated soft fork morphs into a user activated soft fork. Uh, this is to prevent miners from holding the rest of the Bitcoin ecosystem hostage from wanting to adopt these changes. So the 50% is there to sort of make sure that a significant amount of hash rate is ready to enforce this BIP, while not waiting for an overwhelming consensus among all the miners that are in the space. So this is the change that BIP-110 has with respect to the activation mechanism. Usually for SegWit and all those stuffs, you typically it was weighted out for like more than 95% of hash rate signaling for the activation of the soft fork. But here BIP-110 doesn't want to wait till 90% or 95%. It just wants to wait till only 55% of the hash rate is signaled, hash rate signals. So the rationale or idea behind it is that you need at least 55% in order to I wouldn't call it as prevent, but in order to handle or in order to reduce a nasty chain splitting scenario. So the idea is that if you have like 50%, and the rest of the miners see that a significant portion of the network is signaling for this change, they will eventually jump ship and keep adding to the hash rate that enforces this BIP. So that's the whole idea. So let's run through a simple scenario, chain split scenario that could happen. Because in the actual BIP, if there is like 95% hash rate signaling, of course there is a good chance or a decent chance for a chain split. But because overwhelming majority of miners are signaling for the change, and the longest chain will advance much faster than the remaining 5% hash rate that doesn't want to change. So in that case, the chain split will be resolved in a very short span of time, maybe in a matter of few blocks. But in this BIP-110's case, that is not going to be the case, because when there is only 55% of the hash rate signaling for it, and the BIP goes active, there will be a significant chunk of hash rate that is mining in the in, let's say, the older chain or the other chain. In that case, there will be reconciling the chain split will become difficult, because there is near equal proof of work being done on each of the chains that gets split. So this could happen if there is 55% minus signaling by block number 965666. There will be a split. Of course, this there will be no split only if there is overwhelming majority, or if there is very poor signaling, like less than 55%. If there is only less than 50%, then there is no adoption, and the BIP falls flat. If there is 50% or let's say 60% minor signaling for this BIP by block 965666, then there is a potential of a chain split, and the chances of the chain split resolving quickly and seamlessly is less. So you will have to slug it out, and that will be constant switching of allegiances bit among miners, among node runners, and also in the market. So that is the scenario that we are looking at. Some of the criticisms, this 55% is a big criticism, because it's just 5% above the minimum 50% required for at least the chain split to dominate. So that's one criticism. With this sort of thin margin, there will be a lot of volatility. Mining pools will keep jumping, and even the mining pools will be second guessing as to which chain split will become the heaviest. So there will be a lot of uncertainty and hash rate volatility. And change, as I mentioned earlier, the chain split duration will prolong. There will not be a quick and easy seamless resolution. There will be a prolonged prolonged chain split condition happening, and of course economic uncertainty comes along with it. So these are like the main criticisms against BIP-110's design. So yeah, so I think that's all I have for this BIP. If you have any questions, happy to take them.